All right. Good morning. All right. So you have to forgive me. I'm coughing a little today. So we are continuing where we left off in 213, which is the U.S. and metric systems of measurement, length, weight, and capacity. So just to very quickly recap, last time we talked about how with the U.S. system we use something called dimensional analysis. I also call it out with the old, in with the new. And that's where you multiply by a fraction, where your old units are in the bottom, your new units are in the top, and that will make the old units cancel. And then you'll be left with your new units. And sometimes you have to do this more than once. So if you need any examples, please go and see the previous lecture video. Then we closed out dealing with, we didn't close out, we finished the lecture talking about conversions in metric, which all had to do with this little line right here, the different types of units, kilometers, or kilo, hecto, deca, the regular units, deci, centi, and then milli, whether you're talking about meters for distance, grams for weight, or liters for capacity. So you just put your a little dot wherever the unit you're starting with is, you go left or right to the one you're ending with, and the number of times you move in the direction you move is what you do to your decimal. And I believe we stopped with examples 25 through 30. So let's move on to converting units of mass. And again, there is the line that we will use in order to convert from one thing to another. So let's try out 33, 34, and 35. And just moving some things around. Okay, so 33. We got 641 milligrams, and we want to convert this to grams. So we're starting with milli, and we want to end with the thing that is just the regular unit, the one in the middle, regular old grams. So we start with milligrams, which is over here. And to get to grams, we'd have to move left. 1, 2, 3 times. That looks a little ugly. Let me just redo that. Still getting used to this device. There we go. So we're ending up at grams, and we move left 3 times. So that's the same thing that we'll do to the decimal here. So if we write our 641, the decimal is originally behind the 1 since we don't see it. We'll move it left 1, 2, 3 times. And that says we end up with 0.461. 0.461 grams. So 641 milligrams is equivalent to I wrote my 4 and my 6 backwards. I'm trying to do too many things at once. Sorry. 641. So 0.641 grams. All right, for number 34, let's switch our color to blue. I don't want to have to keep erasing things if I don't have to. And we're going from kilograms to grams. So we're going to start over here on the far left where the kg is, or just the K if you don't have the extra letters on the line. So we're starting at our kilograms, and we're going to end up at grams. So we're going right this time. Right 1, 2, 3 times. We actually have the same destination, but a different starting point. So we move 3 times again, but this time it's to the right. So for that 8.5, we're going to move its decimal right 1, 2, 3 times. And we'll have some filler zeros to place. And you can see that you end up with 8,500. So that's 8,500 grams. 8,500 grams is equivalent to 8.5 kilograms. And we said the reason we have these different units is because sometimes the number just kind of sounds better as one unit than the other. Or maybe we have things that usually sound better in their own different units, but we need to convert everything to the same type of unit to be able to do math with them. All right, finally with number 35, we have the 0.0052, and that's DAG, so that's the deca. Remember, deci just has the DG, so the A is to deca, the A after the K. So we're going from decagrams to milligrams. So let's switch our color to, let's do green this time. So decagrams starts right here. So this is our starting point. And we need to end up at milligrams, which is over on the right. Now I'm gonna show the little movement below this time. It doesn't matter if you show above or below. So that's 1, 2, 3, 4 times to the right. So we'll do the same thing to this decimal. So for the 0.0052, we go right 1, 2, 3, 4 times. And the zeros in front are no longer needed because that's a whole number. So this is just 52 milligrams. $52 milligrams is our answer. All right, so that's converting units of mass. I have to clear my screen, and let's go down to capacity. So capacity is when we're talking about volume. So in the US system, we were talking about things like pints and quarts and gallons and fluid ounces, or as I jokingly say, flazes. In the metric system, we have our liters, so kiloliters, decaliters, milliliters, centiliters, etc. And just like the other two metric systems, it's all the same prefixes or prefixes, and they're in the same order. And you're just going to start at 1, you'll move left or right to get to the end, and then you'll do the exact same thing to the decimal. So let's do 37, 38, and 40. Now they do make a special note right here that a milliliter is the same thing as a cubic centimeter, also abbreviated as cc. So a milliliter is the same thing as a cubic centimeter. That's important. If you notice in examples 38 and 39, they're using cc instead of ml or dl or anything like that. So we have to understand that when they say cc, it's the same thing as them asking us to convert it to milliliters. So milliliters and cubic centimeters are equivalent. So if I ask you to convert to cc, this is your destination here at the far right of that line. Okay, so we said we're going to do, what did I say, 37, 38, and 40. So 37, I am holding my pen upside down. We're starting with 3.59 liters, and our destination is milliliters. So we're starting here. And we need to end up at milliliters, which is at the far right. So we're going right. 1, 2, 3 times. So we'll do the same thing to the decimal. 3.59, we'll go right 1, 2, 3 times. There's a filler 0 needed, and that'll now be 3,590. And that's milliliters. We went from liters to milliliters, so 3 times to the right. Now let's do number 38. We're going to go from milliliters to cc. Again, that was cubic centimeters, which is equivalent to milliliters. You have to remember that cubic centimeters are the same as milliliters. So we're going from milliliters to cubic centimeters. Wait a minute, what did I just say? 1 milliliter is 1 cubic centimeter. So milliliters is at the far right, which means cubic centimeters is at the far right, which means we don't move at all. 84 milliliters is the same thing as 84 cubic centimeters. They are exactly equivalent because a milliliter is a cubic centimeter. Let's do 39, just because we'll do all 4 of these, because there's 2 going to that, but this one was the same. So going from liters to cubic centimeters, well, cubic centimeters are milliliters. So we're going to go to the right, which is yellow. So we're starting with liters. We're going right 1, 2, 3 times to the equivalent of the cubic centimeter, which is milliliter. So we do the same thing to its decimal. So for the 0.0075, We go right 1, 2, 3 times. It ends up between the 7 and the 5. We don't need the zeros in front. So that's 7.5 cubic centimeters, also known as 7.5 milliliters. For number 40, we're starting with 57 milliliters, and we want to end up with deciliters. So milliliters is over here at the far right. I'm going to use blue this time. And we got to go left to get to deciliters. 1, 2, and that's it. There's our deciliters. So doing the same thing to its decimal, which is immediately after the 7 initially. Left 1, 2 times, put it in front of the 5. So we get 0.57 deciliters. And that would be our answer. Okay. Let's do one last problem from this section before we move on. I've been focusing mainly on just the direct conversions, but let's see one from a word problem. The height of the Empire State Building is 381 meters, and we want to convert this to centimeters. I don't know why anyone would want the height of the Empire State Building in centimeters, but it's a math problem, so we're going to do it. And you can see above, at the bottom of the previous page, specifically, we have that line, but only with the prefixes, and then meters, grams, and liters all in the center. So again, it doesn't matter whether you're talking about meters or grams or liters, it's all the exact same process. The metric system is wonderful in that regard. So we're starting with 381 meters, and our goal is to end up in centimeters. So we're starting at meters, which is dead center. And to convert to centimeters, we're going to go right 1, 2 times. So that is exactly what we will do with the decimal in 381. So we write our 381. We give it a decimal, which is behind the 1 since we didn't see it originally. And we're going to take that decimal and move it right once, twice, which means we'll need filler zeros. And that makes this 38100. In other words, 38,100. And we are now in centimeters. And there we go. The rest of the problems are pretty similar. You can see 42 below. The average weight of a cell phone is 0.8 kilograms. Convert this to grams. Let's knock that out really quickly. So we're going from kilograms to grams. So we're starting with kilograms, which is over here. And we need to go to grams, which is in the center. So we're moving right 1, 2, 3 times. So we'll take that 0.8. We'll move its decimal right 1, 2, 3 times, which gives us 2 filler zeros. And that tells us our answer is 800 kilograms. Why did I say kilograms? I meant grams. I'm looking at the problem. So a 0.8 kilogram phone is equivalent to an 800 gram phone. It's the same weight, just different units. All right, so with all that in mind, that will close out 3.13. So that means that this section is due next class. So the next class of, 11:59 next class. All right. Clear screen. Go back off annotate. And let's go to 214. Conversions between US and metric system. So I'm just going to pull up maybe. Why is it not letting me do this? Sorry, something just got hidden. There we go. It's not letting me pull up my, there we go. So as a summary from 313, again, we kind of talked about this earlier, 213. For the US system, it was dimensional analysis, which is where you multiply by a fraction old units in the bottom to cancel your old units. Metric system is all about move the decimal the same number of times as your line movement. And what I mean by line is that line with the kilo, the hecta, the centi, the deci, all that stuff. In 314, which is converting between the two systems, you may need to do both of them. So it's generally, you'll have a US system style problem, but you may also have a metric system style problem as well. So for the most part, you're going to be multiplying by fractions with old units in the bottom and new units in the top. But occasionally, our table of conversions doesn't have everything that we need. Like it has going from inches to centimeters, but not inches to kilometers. So if I asked you to go from inches to kilometers, also known as kilometers, you would have to go from inches to centimeters, and that would be using the US style by multiplying by a fraction, but then you'd have to take the centimeter value and move its decimal to turn it into a kilometer value, which is a metric style problem. So not every single one of these is going to be a direct conversion. Sometimes you're going to have to do a fraction multiplication as well as moving a decimal around. So just be on the lookout for that. I can't say that every problem has it or every problem doesn't. It just depends on the problem. All right. No, not that. This. No, not that. This. So we are given another table at the start of this section, and this table is also in your formula sheet. Remember, your formula sheet can be found in the same place that your syllabus can, under Resources in Connect. Under Resources in Connect. So there was a whole bunch of these back in 213, and I think I said 313 again earlier. If I did, I meant chapter 2. We'll be in chapter 3 soon enough. We're still in chapter 2. So we have inches to centimeters, we have feet to meters, we have yards to meters, we have miles to kilometers. Please remember that meters are M, miles are MI. This is a big issue that students have moving forward. I don't want to say a big issue, but an issue. We also have converting pounds to kilograms and ounces to grams under the weight. So there's only 2 of these. And then under capacity, we have that a quart is 0.95 liters. And a fluid ounce is approximately 30 milliliters, which would also be 30 cubic centimeters. Now, the decimal precision is different for all of these. 1 ounce is 28 grams. You might not be able to see this, but it's a squiggly equal sign, which means it's close. They're all close. The only one that has an actual equal is 1 inch is 2.54 centimeters. Which means that in reality, the answers might be off by a couple of decimal places because these are rounded values. It's not just 1 mile is 1.61 kilometers. It's like 1.61 blah, 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 blah kilometers. Most of these go on and on forever, kind of like the number pi. All right, so again, when you get your problem, you want to look at what you're starting with and what you're ending with. If you see a direct conversion, then just use that one as a fraction. But you might not always see that. For instance, in number 3, this says to go from feet to centimeters, but this says going from feet to meters. So what we'll have to do in problem 3 is go from feet to meters, and then from meters to centimeters. Okay. So let's do problem 1. We're starting with 10 inches. I need to put my pen on. we go. We're starting with 10 inches. And it says to convert to centimeters. Well, 1 inch is 2.54 centimeters. So we take our 10 inches, and we're going to multiply this by a fraction. And the numbers that go in the fraction are going to be based on the conversion. 1 inch is 2.54 centimeters. So maybe the 1 inch goes in the top, maybe it goes in the bottom. I don't even really want to focus on the numbers in the units. Let's just say, all right, we started with inches, so we know out with the old and with the new. If we're starting with inches, the inches have to go in the bottom. They absolutely have to go in the bottom of the conversion to make sure that they cancel. See, inches in top, inches in bottom, they'll cancel. But then I have to write the rest of the stuff. How many inches is how many centimeters? Well, 1 inch, that's 1 inch in the bottom, is 2.54 centimeters. So the 2.54 centimeters goes in the top. And then we can pull out our calculator. This is a multiplication problem. I don't want to always pull my calculator on the screen because it takes a lot of time to go between annotate and et cetera, et cetera. So 10 times 2.54, and that's just going to be 25.4. You might have been able to do that really quickly because multiplying by 10 just moves the decimal right once. So 25.4 centimeters. And I'm just going to leave it here instead of writing it in the box. Okay, so 10 inches is approximately 25.4 centimeters, or they say it is exactly, because that's the one with an equal sign. Number 2, going from 650 feet to meters. So do we have something that goes from feet to meters? Well, not the first one. Second one, feet, meters, feet, meters, feet, meters. Yes, we do. We're going to use the second one. So we start out with our 650 feet. And we know we're going to multiply this by a fraction. And in that fraction, the old units have to go in the bottom. We know that before doing anything else. We know that feet have to go here. Even without knowing that there's a conversion up there, that would be true. But we do know that 1 foot is 0.305 meters. So I'll put the 1 foot in the bottom, the 0.305 meters in the top. And then we'll do our product. That's 650 times 0.305. 650 times 0.305. And we get 198.25. We know our feet units are gone, so we're stuck with meters. But if you pay attention to the instructions, if this was a connect question, it would mark it wrong, because they say to round your answers to 1 decimal place if necessary. So that says we're rounding where the 2 is, which means we look at the 5, that'll round up. So this is going to be about 198.3 meters. That would be our answer. All right, problem 3 is definitely one of the more interesting ones. So we got 0.8 feet and we're converting this to centimeters. We got inches to centimeters, that's no good. We got feet to meters, that's not gonna do the job. It's got feet, which we're starting with, but it's going to meters. That's not exactly what we want. Maybe we're gonna use it, maybe not. Yards to meters, nope. Miles to kilometers, nope. We have to have something with feet. The only thing with feet is the second one. So we have to use the second one, but that converts to meters. So we're gonna need a middleman, because then we're gonna have to go from meters to centimeters. So we're gonna go from feet to meters to centimeters. Going from feet to meters, we start out with the 0.8 feet. We know we're gonna multiply by a fraction. My mouse just disappeared. That's not good. What's going on? There we go, okay. Color. Sorry about that. Technical problems are always fun. So the 0.8 feet, we're multiplying. What is happening? Oh no. My computer is being funny. I knew this was going to happen. Let's give it a minute. Sorry, everyone. I don't know what's happening. I really, really, really hope this is not going to do what I think it's going to do. All right. Hang tight for a second. Let me see if I can get this. All right, I think I'm back. I think I'm back. All right, so 0.8 feet. Got to get my bearings straight again. All right, so 0.8 feet. We're starting to convert this to meters. All right, so out with the old, in with the new. So we know that feet have to go in the bottom, and we know that 1 foot is 0.305 meters. So 1 foot is 0.305 meters. So that way the feet will cancel. And then we're going to do our math. 0.8 times 305. 0.8 times 0.305 specifically. And that'll give us 0.244. And now we're in meters. Pay attention to your units. Don't just write the numbers, write the units, please. And thank you. All right. But that's not what we want. We want to convert this to centimeters. So what we're going to have to do, and I'm going to write this to the side, is use the metric conversion. We had our line with all the different stuff. We had kilo first, then we have our hecto, more specifically. Then we have our deca, that's the DA. Then we have the regular, we're talking about meters, so I'll write M for meters. Then we have our deci, that's just a D, our centi, that's a C, and our milli, which is an M. Maybe I should write the word meter here. There we go. All right, so we're starting with meters and we want to go to centimeters. So we're starting here and we're gonna go right twice to get to centimeters. So that's the same thing that we're gonna do to this decimal place. So the decimal goes right twice. So that'll go behind the 2, then behind the first 4, which will give us 24.4 centimeters, 24.4 centimeters. Alrighty. Problem 4 is not too bad. 1.25 meters to yards. We have meters to yards as the third one, so that's only going to be a single conversion. So we'll write our 1.25 meters. We're going to be multiplying by a fraction, out with the old, in with the new. We know that meters have to go in the bottom so that they'll cancel. That's the entire concept of dimensional analysis. Everything else just goes in place now. So it was meters to yards, so it was 0.914 meters is 1 yard. Now, because the 0.914 is in the bottom, that means we're going to be dividing this one. So we got to take our 1.25 and divide it by 0.914. And that's going to give us a big number. Well, not a big number, but a number with a lot of decimals originally, 1.36736, et cetera, et cetera. I'm just going to write a few decimals at first, but we're supposed to round this to 1 decimal place. And that was in yards. So we'll look at the 6 that tells us to round up, and that's going to become 1.4 yards. Alrighty. So that's converting lengths from US to metric or metric to US. Now, how about we try some of the weight and mass, going between ounces and grams, grams and ounces, etc. So there's only two conversions to use going between weights and masses from US to metric. In the US system, we call them weights. In the metric system, we call them masses. The science behind that is that your mass is the same on every planet, but your weight would be different. Weight is affected by gravity, mass is not. I don't exactly know why the metric system decided to use mass and we decided to use weight, but it is what it is, as they say. Fortunately, it's the same exact math that we're doing as before. So 4 ounces to grams. Well, luckily, right here, the second one in the middle column, ounces to grams. So we start with our 4 ounces. We're going to multiply by a fraction. And out with the old. So ounces have to go in the bottom. We're converting to grams, and 1 ounce is 28 grams, so we can put the rest in there. 1 ounce in the bottom, 28 grams in the top. So we're back to multiplication, and we're going to do 4 times 28, which should be 112, I believe. Yes. 112 grams, because our ounces are gone. So that's our answer, 112 grams. This next problem goes the other way around, grams to ounces. So we're starting with 9 grams. We're going to multiply by a fraction. And out with the old and with the new. So grams have to go in the bottom. And we're going between grams and ounces. 1 ounce is 28 grams. So that says the 28 goes in the bottom because that's where the grams are. The 1 ounce goes in the top. Now that 9 is in the top because it's a whole number. The 28's in the bottom. So we are dividing those. You have to make sure you're doing the correct operation. The grams will cancel. Out with the old. You're left with ounces. And 9 divided by 28 is 0.3214, blah, blah, blah. So that's ounces, which when we round that to 1 decimal place, we're looking at the 2, which is to round down. So that's going to be 0.3 ounces. Let's skip number 7 and do number 8. And I'm going to try and leave this on the screen for now. We're going from kilograms to tons. Kilograms to tons. Well, up here, I only see kilograms to pounds, so uh-oh, that seems like a problem. But if you have your formula sheets on you, which you should when you're working on homeworks, quizzes, and tests, you should go ahead and print them so they're out in front of you. If you go back and look at the previous table, I'm leaving that on the screen. Sorry, it's going to look a little ugly for a second. But if you go back to the previous table, we saw that 1 ton was 2,000 pounds right here. So 1 ton is 2,000 pounds. That's going to help us finish this job. 1 ton is 2,000 pounds. So I'm just going to write to the side over here. 1 ton is equivalent to 2,000 pounds. So we're going to be able to go from kilograms to pounds using this conversion right here, the first one from this table in the middle. And then we'll be able to go from pounds to tons using this. So we got to go from kilograms to pounds to tons. To go from kilograms to pounds, again, that's this one right here, out with the old. So we start out with 8,200 kg, and we're going to multiply by a fraction. And our fraction will have the old units in the bottom, kilograms. Well, specifically, 0.45 kilograms is 1 pound. So 0.45 kilograms goes in the bottom, 1 pound, or LB, goes in the top. That will get rid of the kilograms, and now we are in pounds. Cancel your units as you're going through. Make sure your new units are there. But we don't want pounds, we want tons, so we got to do this multiplication jazz again. We got to multiply by another fraction. Let's go with black. So we're going to multiply by another fraction. Now the old units are the pounds. We're trying to get rid of these pounds. So pounds go in the bottom. And we know that 2,000 pounds is 1 ton. So that's 2,000 in the bottom with the pounds and 1 ton in the top. The pounds will cancel. And this tells us that we're doing 8,200 divided by 0.45 divided by 2,000. Again, any number that's in the bottom of a fraction counts as a division. So if you pull out a calculator and show your math, 8,200 divided by 0.45 divided by 2 grand. You should get 9.111111111, and that's in tons, but we're rounding to 1 decimal place, which will end up being 9.1 tons. Because you're looking at the 1 in the hundreds place. Hundredths. I said hundreds, didn't I? Hundredths. And that tells us to round down, so it's 9.1 tons. All right. Let's scroll down. So I got to clear my screen. Let's do a couple of these. I don't want to scroll down that far actually, because I want to leave the conversions up top if we can. I'm going to scroll out just a little bit. Hopefully that's not too small for everybody to read. Okay, there we go, perfect. So 5 quarts to liters, quarts to liters. Well, this top right one is quarts to liters, so we can use that. 1 quart is 0.95 liters. So we start with our 5 quarts. We know we're going to multiply by a fraction. And we know that quarts have to go in the bottom. We're converting to liters, and that is quarts to liters. And we see that 1 quart is 0.95 liters. That'll cancel our quart units and leave us with liters. This is a multiplication, 5 times 0.95. And that should give us 4.75 in liters, but we have to round. The 5 tells us to round up. So that'll be 4.8 liters. Let's do one more of these. Let's do number 10. So 90 milliliters, and we're converting this to fluid ounces. Milliliters to fluid ounces. Remember, a milliliter is a cubic centimeter. So whether you're converting between either of those two things, 1 fluid ounce is 30 of the other. And we're going between milliliters to fluid ounces. So we're going to use this. 1 fluid ounce is 30 milliliters. So we start with our 90 milliliters. We know we're multiplying by a fraction. Out with the old, in with the new. So our milliliters are going to go in the bottom. Specifically, 30 milliliters is 1 flas, or fluid ounce. And the milliliters will cancel. 90 divided by 30 is 3, exactly. So that is 3 fluid ounces. Now this is still an approximation because 1 fluid ounce is about 30 milliliters. It might be like 29 point something, it might be 30 point something, but this is not exact. Most conversions between US and metric are not exact. Most of them are not exact. Most of them are rounded values. All right, so with our last bit of time, we can move on to the next section since we've practiced our conversions. We've done US to US, we've done metric to metric, we've done US to metric and metric to US. And this has been on length, weight, and capacity. There's one more style conversion that we've yet to talk about, and this one's a little more unique because, well, let's just get into it. Clear screen. take off annotate, switch, here we go. So our last conversion, our last section, I thought my screen was freezing again. I was a little worried, is temperature conversions. Temperature conversions are the most interesting style of conversions because 0 degrees Celsius is not 0 degrees Fahrenheit. Every other conversion we've done so far is something called proportional. And if something is proportional, it means that 0 in one unit is 0 in the other unit. And the basic idea that we talk about in quantitative reasoning when something is proportional is that if you double one, then the other is double. So if I said, what do we say? 1 inch was 2.54 centimeters. So if I had 2 inches, I can just double the 2.54 because they're proportional. Or let's say 1 foot is 12 inches. If I had 2 feet, that would be 24 inches because if I double one, the other is doubled. Again, that does not work for temperature. Temperature is an interesting beast. Specifically, 0 degrees Celsius is 32 degrees Fahrenheit. When the temperature conversions were created, when the metric system was created in Celsius, what they wanted to do was to make everything based off of water. So metric system is all about powers of tens. The US system, which is quite ancient, and in the 80s we even tried to get rid of it. I think it might have been before the 80s as well. And it failed miserably because everybody likes what they're used to. But the metric system is more amazing in my opinion because it's all about powers of 10. 10 of this is 100 of this, is 1,000 of this, is 1 of this. It's a lot easier to convert. As you saw, we just move left and right on a line and that's it. You go home and a lot quicker instead of the dimensional analysis stuff. So what they said is, all right, let's make the boiling point of water 100 and let's make the freezing point of water 0. Now, you might say, why not 0 and 10? Because a lot happens between 0 and 10. We get, in terms of Celsius, we're usually, comfortable between 20 and 30 degrees Celsius. I don't exactly want to say because, opinions vary. Whereas in Fahrenheit, we're comfortable more like in the 50 to 80 range. So it's a wider array of numbers. So they wanted to go from 0 to 100. Well, previously, the older system Fahrenheit, we said water boiled at 212 and it froze at 32. So they just did a linear system and made 32 and 1 0 in the other, 212 and 1 100 in the other, and they came up with these equations. It's actually very basic linear algebra stuff that you could learn in Math 5. So to convert from Celsius to Fahrenheit, this is your formula, and we give it to you in fractions and decimals. We don't care which one you use. And if you wanted to go from Fahrenheit to Celsius, you use one of these two, and we give it to you. One is one with a fraction and one with a decimal. This is actually a fraction and a decimal. In my opinion, I don't like this one because it mixes fractions and decimals, but it's not bad. It's just an opinion. I always use the 5/9, but there's nothing wrong with doing f minus 32 and then dividing by 1.8, but you got to keep your order of operations straight. Same with the first one. So how do you know which one to use? Well, you have these in your formula sheet. You don't have to memorize them. If you start with Celsius, you need to be plugging these into the right side because the other thing just says F equals. That's the thing we need to get. If we start with C, we need to plug it into the thing that says F equals. If we start with a degree in Fahrenheit, we need to plug it into the thing that says C equals. If you plug a number into the left side, you're not going to know what to do. It's to plug it into the right side, then you're just going to do arithmetic. You'll multiply it by your 9/5, you add your 32, and boom, you get your F. Okay. So let's try these out. Annotate. We got 35 degrees Celsius, and we want to convert this to degrees in Fahrenheit. And before I start this problem, I want to mention that when we talk about temperature, in the real world, almost nobody ever says the temperature and then degrees Fahrenheit or degrees Celsius. If I asked you what the temperature outside is right now, maybe you'd probably say 55 or 62 or 81. You wouldn't say 55 degrees Fahrenheit or 62 degrees Fahrenheit or 81 degrees Fahrenheit. But the problem is, if you're talking to someone from England, they might think it's really, 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 really hot outside because they're used to dealing with things in Celsius. But if you specify degrees Fahrenheit, they're going to go, oh, okay, that's probably not that bad. So 35 degrees Celsius. Since we're starting with the Celsius, we want to plug it into one of the F equals, because if you plug it in to one of the bottom ones, you'd have 35 equals and then all this stuff, and you'd have to algebraically solve for this F, which we have not taught you how to do yet. Now, if you know that technique, you can do it, but it's just going to be a lot easier to plug it into one of the tops. Again, I don't really have a preference for what you do. I always use the 9/5. That's my particular process. So I'll go F equals 9/5 times the C represents the temperature in Celsius, and that's the 35 degrees Celsius right here. So 35, and then plus the 32. And you can just jam this into a calculator. You can show your work. It's up to you. Remember, calculators are allowed for the back half of chapter 2. So 5 will go into 35 7 times. And then we're doing 9 times 7, which is going to be 63. And then the 63 plus the 32 is going to give us 95. So that's 95 degrees Fahrenheit. That's a rather warm temperature if you're considering it to be the weather. So 35 degrees Celsius, that tells me that's a really, really, really warm day. A lot of people are going to be sweating, unless they're in Arizona where there's no humidity, then maybe not. All right, let's try another one. Let's go from Fahrenheit to Celsius now. 86 degrees Fahrenheit, converting that to Celsius. So since we're starting with Fahrenheit, we want to plug it into the equations that say C equals. Now again, I don't care which one you're using. I have a preference to use the first one, so I use the first one. C equals 5/9, parentheses. F means the temperature in Fahrenheit, that's the 86, minus the 32. You got to do the inside of parentheses first. 86 minus 32 is going to be 54. So that's 5/9 times 54. Again, you can jam this in a calculator. The reduction happens nicely though. 9 and 54 will reduce. 9 will go into 54 6 times. That's a 1 and a 6, which means we're just doing 5 times 6, which is 30. So our temperature in Celsius is 30 degrees Celsius. So 86 Fahrenheit is 30 Celsius. 86 might be a little warm to some. I'm particularly comfortable at 86, so that means an 86 degrees Fahrenheit. If I wanted to say where I'm comfortable at, I could say, well, roughly 30 degrees Celsius, maybe a couple degrees cooler. All right, this is a pretty short section, so let's just knock out all the problems here. So problem 3, the boiling point of the element osmium is 9,080 degrees Fahrenheit. That's a very, very high temperature. Water boils at 212 degrees Fahrenheit. This element, osmium, its melting point is at least 40 times higher than that. Find the boiling point in degrees Celsius rounded to the nearest degree. So we're rounding to the nearest whole number here. So this is an F. So we're going to use an equation that says C equals. So C equals, and again, I don't care which one of these you're using. I have a preference to use the first one. So that's 5/9, parentheses, then that big number, 9,080, minus the 32. And once again, you do not have to memorize these formulas. So the 9,080 minus the 32, what's that? 9,048. So that's 5/9 times 9,048. I don't think 9 is going to go into 9,048. It will not. It will not. So let's just take the 5, divide it by the 9, and then multiply by 9048 in our calculators. And we'll end up with 5,026.66666 or 6 bar, which we're supposed to round this to the nearest whole. 6 tells us to round up. So that's 5,027. And now we are in degrees Celsius. It still seems like a rather large number. Also, some of you may have heard of the temperature in Kelvin. We're not going to be doing any of that in this course, so don't worry about it. But Kelvin is just taking a Celsius number and adding or subtracting another number. I'm not even going to say what it is because it's a non-issue. All right, question 4. This is a question I'd love to ask in my quantitative reasoning class. You know I love referencing that because so many of you will go to it next. Maybe not mine, but someone's. They give you a number and ask you if it's a hot or a cold day. Now, because most, if not all of us are Americans, we're used to temperatures in Fahrenheit. So if we saw 5, we know that would be very, 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 very cold. But maybe it's not that cold in Celsius. Maybe it's hot. Maybe it's not. But let's find out. Let's convert it to something we're used to. And since we're given Celsius, we need to use an equation that says F equals. Again, it doesn't matter which one you use. I'll mix things up. I'll go against what I like to do. And I use the 1.8. So that's 1.8 times the temperature in Celsius. That dot's a little low. I don't want that to look like another decimal. Times the temperature in Celsius, which was 5. And then we add our 32. So 1.8 times 5 plus 32. Well, 1.8 times 5 is going to be 9. That's 9 plus 32, which is 41. And that's going to be in degrees Fahrenheit. So that's the temperature. So is the outdoor temperature of 5 degrees Celsius a hot or a cold day? I think most of us would agree that it's cold. Unless you're just super, super, super used to cold weather. Maybe you come from the Midwest where your winters are negative 20 degrees Fahrenheit. And then you're like, oh, 41 degrees Fahrenheit. That's a warm day. Let's go out in shorts. I don't know. Again, these are opinions. But most people, especially in Hampton Roads, would say that that's a cold day. Alrighty. So I know that I'm not able to give you time to just work on these on your own since it's a very different format. So we've moved through things a little quicker than usual, but that does close out chapter 2. I do not want to throw entirely too much material all at you or at you. Let me start over that sentence. I don't want to throw too much at you in one lecture. So this covered a good 2.5 sections. That's plenty for one lecture. So we'll cut it a little short on time, but that means that annotate. Let's go back to Word. Oops, I need to clear my screen. There we go. Lots of little controls. So homework. And I did write 3 earlier again. 2.14. So 2.13, 2.14, and 2.15 are all due by 11:59 p.m. next class. I will update those and connect in the next hour. I will also be uploading this video to YouTube and then putting that link in Canvas for those of you who were not able to watch it live. And since that finishes chapter 2 material, that means that once you finish the homework and the quizzes, you should be able to take the test. Now remember, test 2 part A only covers sections 1 through 8. So when you have those done, you can go ahead and knock out that test. Then when you have 2.9 through 2.15 done, you can knock out that test, part B. Now remember, technically part A is no calculator. Whether or not I can monitor that, I understand is a complication. But remember, I do have expectations of your abilities moving forward, especially if you have me in a math class later. I might not say you're allowed to have a calculator. My quantitative reasoning class, I always let students use calculators because that's a, quote, math in the real world class, which we always have calculators. But if you're going on to pre-calculus, myself as well as many other teachers don't always allow calculators. You've got to make sure that this stuff is learned. All that fraction math we learned in chapter 1, you need to retain that information. All the decimal math, you need to retain it, especially things involving percents that's always going to be popping up in other math classes. All right, so if you have any questions, please email me. I remember there is a discussion board set up in Canvas that you can ask questions. If anyone's asked a question and you know an answer, please, 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 please help them. Remember I said that I'm not always going to be the one answering. I want to see student participation as well. And if you need any quick quizzes, reset, if you need extra attempts, please email me and let me know. Besides that, have a good day, and we will catch you on the next one.